Good morning to all. I am Romila, Assistant Professor of IT. I handled this subject this semester. Subject code is CS3452-Theory of Computation, second year, 4th sem IT students. Core outcome is Theory of Computation. CO1 Construct Automata Theory using Finite Automata. Finite automata defines how machine process input string and decide whether to accept or reject them using finite automata. Finite automata means it involves discrete input and output values. And then CO2 write regular expression for any pattern. CO3 design context free grammar and full-stone automata. CO4 design Turing machine for computational functions. CO5 differentiate between decidable and undecidable problems. Syllabus is Theory of Computation. Unit 1 Automata and Regular Expression. Unit 2 Regular Expression and Languages. Unit 3 Context Free Grammar and full-stone automata. Unit 4 Normal Forms and Turing machine. Unit 5 and Decidability. And then first one is Theory of Computation definition. Definition means computer science that deals with study of algorithms, their properties and their efficiency. Algorithms already know step-by-step process. And then important topics of TOC: automata theory and computability theory and complexity theory. These important topics purpose to understand the fundamental capabilities and limitations of a computers and algorithms. What is automata theory? Automata theory is a branch of theoretical computer science that deals with abstract machine and computational process. Abstract machines is a theoretical model of computer system used to describe how program executes. And second one is it involves study of mathematical model of computation. Mathematical model of computation such as finite automata. Finite automata is already know discrete and input and output values. And full-stone automata, Turing machine. And next one is need for automata theory. Need for automata theory, it involves foundation for understanding formal languages, their syntax. Syntax means correct format and arrangement of symbols in languages. And semantics, semantics means the meaning of behavior of valid statements in compiler design and natural language processing and database system. It helps in designing programming languages and compilers. And many algorithms rely on finite automata. The finite automata theory is crucial for algorithm and design and analysis. Next one is finite automata, FA. Already know FA means discrete input and outputs. And second one is finite number of memory configuration is called states. And set of transition based on input symbols from an alphabet name is summation. Uses of finite automata. One example for lexical analysis. Lexical analysis means recognizing a string. Finite automata used to do lexical analysis. And diagram for FA, recognizing shift. Starting state to S0 and going to next state is input string is H, and then going to next state is S2 and input string is I, and going to next state S3 and input string is P, and going to S4 and the final string is shift SHIP shift, and then final state is double circle state. And types of finite automata is different. Two types, deterministic finite automata DFA and non-deterministic finite automata NFA. Deterministic finite automata is a recognize regular languages. Regular languages means containing A and B and then zero even number of zeros, and identifiers means letters or digits and so more. And DFA is defined 5 tuples denoted by M. m equal to q comma summation comma delta comma and q naught comma f, and pi tuples are denoted or q means is a finite non-empty set of states, and then summation means input alphabets, and then q naught is a start state, f is a final state and otherwise called accepting state, and delta means mapping function. And then important point of DFA, for every state and every input symbol there is exactly one unique transition. And then another type of FA means non-deterministic finite automata, is a type of finite automaton where multiple transitions are allowed for the same input symbol. Note the point, multiple transitions are allowed for the same input symbol including epsilon moves. The NFA is formally defined a phi tuple. The phi tuple denoted by the m equal to q comma summation comma delta comma q naught comma f, and then phi tuples denoted are q means non-empty set of states, and summation means input alphabets, q naught means start state, and f means final state or accepting state, and delta means mapping function. One more point is note this place, q into summation to 2 power q power of q. And then important point of NFA, single state on a single input symbol, multiple states are possible. And then next one is DFA and NFA differentiate, accepts are going to, and first accept is definition for NFA. Already know definition of DFA and NFA is DFA means exactly one transition, and then other hand side of NFA is 0 or 1 or many transition may be exist. And then second accept of next state, only DFA means only one possible next state, and NFA means multiple possible next states. And then third aspect of transition of function means DFA delta q into summation of q, and then NFA means q into summation of 2 power q, power set of q. Already know q into summation of 2 power q is a NFA. And then the fourth accept of epsilon moves. Epsilon moves, then the DFA is not allowed, and other hand of side NFA is allowed, can move without input. And then fifth accept of computation path is DFA, single computation path, and NFA means multiple computation paths. And accepts of sixth one is acceptance of string. Acceptance of strings in DFA means the unique path, and then another hand side of NFA is least one path. And then seventh aspect of dead state is DFA required if transition is missing, and then other hand side of NFA is not required. And then eighth one aspects of DFA and NFA difference in implementation. Implementation means DFA very easy to implement, and NFA means difficult to implement and directly. And then aspects of ninth one, number of states. DFA means usually more states, and other hand side of NFA is usually fewer states. And then aspects of 10th one, power of DFA is equivalent to NFA, and NFA power of equivalent to DFA. And then converting DFA to NFA. NFA, first one is NFA given NFA transition diagram, and then note the diagram. Q naught is a start symbol, also is a final state, and Q naught input string 0 goes to Q1, and then 1 goes to Q1 goes to 1 is Q2, and then Q2 goes to 0 Q naught, and then Q naught is a one loop state 0, and Q1 one a loop state Q1. And then step solve this sum. First step is NFA transition table. First First one is states and then input simple zeros are 1. First state is q naught. Q naught means start state and also called final state. Q naught 0 going input string going to q naught comma q1 and then 1 going to pi. Pi means dead state. And then q1 state 0 going to 0 input single or is pi and 1 input string going to q1 comma q2 and state q2 going to input string 0 is q naught and then 1 input string going to pi states denoted as pi means dead state. And second step is DFA construction. Each DFA state is set of NFA states and then DFA state start state is q naught and other ways final state is q naught and DFA transition is the union of all NFA transitions. And then step 3 is DFA transition table. DFA transition table, first one is DFA state is given and then zeros and ones and DFA state is q naught first state is start state and q naught state is going to 0 input is q naught comma q1 and then 1 input string is pi state and then new state is available for DFA state q naught comma q1 and the next state is q naught comma q1. Q naught comma q1 going to input string is 0 is q naught comma q1 and then 1 input string is going to q1 comma q2 and then this point of states new state is q1 comma q2 and then q1 comma q2 is a DFA state. DFA state is 0 input string going to q naught and 1 input string going to q1 q2 and then step 4 final step is DFA transition state diagram and then q naught is a start state always final state and then q naught where q naught is accepting these states are those are the final states. So q naught is a final state and q naught comma q1 all of also final states and the state diagram means a transition table see in the draw DFA state diagram and q naught is a start state and also final state and the input string going to q naught comma q1 also final state and then q1 naught comma q1 is a loop state of 0 and then q naught comma q1 going to 1 input string is q1 comma q2 and q1 comma q2 the loop state is 1 and then 0 input going to q naught and then q naught is going to input string is 1 is a q1 state. And the convert to NFA to DFA is a important points of first one is DFA states are subsets of NFA states. DFA exactly one transition already know for each input and language accepted by DFA equal to language accepted by a NFA. Data state is added if any transition is missing. And then final one is today PPT of summary, definition of TOC and automata theory. Finite automata is only discrete input and output values and finite automata is here two types. One is DFA. DFA means exactly one unique function and NFA means multiple next state are possible and differentiate between NFA and DFA. And thank you so much.